Hello friends, welcome to Joy of Life. So today we are going to look at another medium level problem from Leetcode. The problem number is 240. Search a 2D matrix. It's the second problem. The problem says that write an efficient algorithm that searches for a target value in a m into n integer matrix. The matrix has the following properties. Integers in each row are sorted in ascending from left to right. Okay. Integers in each column are sorted in ascending from top to bottom. Okay, so here we are given with a matrix. As you can see, there are 5 rows and 5 columns, and each of the row is sorted. So 1, 4, 7, 11, 15. It's increasing all the values 2, 5, 8, 12, 19, 3, 6, 9, 16, 22, and so on. And similarly, the columns are also sorted 1, 2, 3, 10, 18, 4, 5, 6, 13, 21, 7, 8, 9, 14, 23, and so on. So we need to find the elements of 5. If 5 is present in this matrix, we need to return a true. So this function returns a boolean, and we need to return the item. We need to return a true if the item is present. If not, we have to return a false. So we are going to look at the problem in details and understand each and every parts of the problem. But before you look at the solution, as I always recommend, to give it a try yourself. The array problems are always interesting, and there are a couple of hints also. You can see that the rows and the columns are sorted. So try to make use of them and try to come up with a solution. Of course, one of the naive solution could be traversing the entire array from by row and column, and then finding the element that you are looking for, and then returning a true or a false, depending on that. But yeah, try to optimize the solution and try to see if you can come up with something better than that. And of course, you can continue this video anytime you wish to. So let's head over to the board and check out how the solution looks. So here I have taken the same example from Leetcode, and this is going to be our input array. And let's say the element that we are looking for is a 5. And as you can see, the 5 is located over here. So as I just mentioned, so what you can do is you can use two loops, right? You traverse the rows and the columns, and then you iterate over the number of elements that is present there, and then you come up with a true or a false, depending on 5 is present or not present, right? So as we see in the problem that it's a m into n matrix. So what is going to happen in that case is your complexity is going to be order of m into n, where m is the number of rows and n is the number of columns. So you're going to traverse over every element. So going with this solution over here, the order of mn solution, here we are not basically leveraging any of the properties given to us. Had it been a random array also, we could have done this and come up with the solution. So since we have been told that it is sorted both in rows and columns, let's use that and try to understand how we are going to capitalize on that. So I have taken the entire array over here, and we are going to look how we are going to solve this. So once again, this array is sorted. So as I have told earlier also, when the array is sorted and we are doing a search, there has to be a solution which operates on order of log n complexity, right? So there is a solution to this problem with order of log n complexity, but it's a very difficult solution to present during an interview. It's a very tricky solution that is there. So we are going to look at a different solution which is not as efficient as order of log n, but it is better than order of mn. So if you see this array, so one thing you'll notice is that sitting at this particular cell over here, there are, so just think that you can go both horizontally and vertically. Okay, so there are two ways you can go. So one way is this way, the other way is this way, and at both the ways if you go, you will see that the values are increasing, right? So similarly, if you start from this end also, and if you check at both the ends, so you will notice a thing that both the values are decreasing. So what do we do in a binary search? In a binary search, we basically go to the mid, and what we do, we go left or right if the mid element is not the element that we are looking for. So here at both the edges, this left top edge, this edge over here, and this edge over here, what do we see is both the values are either increasing or decreasing. But interestingly, if you omit these two edges and take this edge over here, so if you go down, it always increases. If you go left, it always decreases. And just see that this is true for this cell as well. So we have a cell over here 18, right? If we go right, it increases. If we go up, we decrease value. So we can pick either of the edge and try to come up with the solution. So let's see how. Okay, so I have made another copy of this array, and let's say we are looking for the item called 21. Okay, so let's say we start over here. We start here. So we know left we decrease, down we increase, right? And since this is at the right top corner, we can go either left or down, right? So we are looking for 21. The current value is 15. We want something higher. So we have to increase value. So what are we doing? We are going down. So we came to 19, right? So we want 21. So down we increase value, right? So we want 21. Now what happens is we want to increase value. We are at 19, we want to increase value. So we come over here, we come down. So we are now in a cell which is 22. And we now want to decrease value because we are looking for 21. To decrease value, what do? We go right. So we came here. We are at 16, right? So what do we have to do? We have to gain value, right? To gain value, we go down. Then we came to 17. We still want to gain value because our required value is 21. So we go down. So we came to 26. Now we are at a cell and we need to decrease value. So we go right. We came to 23 and we still need to decrease value. So we go right. And now we see that we have found the match that we were looking for. And that is going to be our result over here. That it is true that we found 21. So let's take another example and see. So let's say this time we are looking for something called 50, which does not exist over here. So we are at 15. We need to increase value. So we go to 19. We need to increase value. We go down. We come to 22. We come to 24. We still need to increase value. We come to 30. And at this point, I know this element cannot be present on this row. So this element will surely be less than 30, right? So there is no point going to my left. So I'll try to go down and I see that I have hit my boundary. So this value 50 cannot be present over here. So what do? We return a false. So let's say that the value that we are looking for is say 10. So we start here at 15. We know that all the elements to the left is smaller, right? So we have to decrease value to reach 10. So we go left. We need to reduce even further than 11 to reach 10. So we go left. So at 7, I know all the values to my left is going to be smaller. So 10 cannot be over there. So I have to increase value. So I increase value. I go down. Right. We come to 8. We need to increase value. We come to 9. We need to increase further values. We come to 14. We know that we need to decrease value. So we go left. We come to 13. We know we have to reduce value further because if we go down, the element is surely greater than 13, right? So we come to left and we get a 10 and we find the answer. So we have seen all the examples so far with this. So let's see how it will be with this. It's going to be very similar actually. So let's say we are looking for the value 22. So we start from 18. Now the rule is slightly different. To increase, go right. To decrease, go up. This rule over here, right? Unlike this one. So 18, we need to gain value. So we go right. 21, we need to gain value. So we come to 23. Now we are a value higher than what we are looking for. So it cannot be on my right. So this part is negated. So I have to go up to lose value. So I come over here. I got a value which is lesser. I have to gain value. So I go right. I have to gain even more. So I go right. Now I have to lose value. So I go up. So you see the element has been identified. So this is the solution all about. This is a very simple solution. This is better than order of mn solution that we have seen earlier. So this actually what you are doing is you are doing this as a runtime complexity of order of m plus n. So let's understand its worst case performance. So what happens is you start from this cell over here. So either you go left or you go right. So the furthest element we have is 18, and let's say we are looking for this 18. To we have to gain value, so we come over here. We have to lose value, so we have to go over here. So here we have to gain more value, we come over here. We still need to gain value. You have to come over here. You still need to gain. You have to come over here. And now you need to lose value. So you start going towards your right. And you finally reach 18. So you see here how many cells we have touched. We have touched 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have touched m plus n. So m plus n is going to be 5 plus 5. So to find a path, you are not going to touch more than m plus n. That is more than 10 cells you are not going to touch. So this is the solution all about. So let's head over to Leetcode and see how it looks on the code. We will take this approach. It's going to be the same for both, but we are just using this one over here. Okay. So we are starting from I equals to 0. So the first row and the column is going to be the last cell in that column, right? So we are going to take matrix 0 dot length minus 1, right? So it's this ij is now pointing to the uh, top right corner of your matrix. Okay. So what is going to happen in this case over here? So our row and column could change. So our row could decrease, our row could increase, and our column could decrease only. So you'll see that we are never going right, because the entire right part we are eliminating and taking a decision, right? So our termination condition is going to be matrix dot length. It should be less than matrix dot length I, because I is always incrementing. Keep in mind that it's the row, so we are incrementing the row, and j is decrementing, and so j should be greater than equals to 0. So this becomes our termination condition, right? And what are we going to do inside? So we are going to check if matrix I j is equals to the target. So this is one case that we are sure of. If we have found the element, we are going to return a true immediately. Otherwise, we have two checkpoints. So matrix ij, if this value indicated by this cell is less than the target, so what do we do now? We have to gain value. And to gain value, what do we know? To gain value, we have to go down. So go down means we have to increment our row but stay in the same column, right? So we are just going to do I plus plus. So the other case is when the target is greater. So when the target is greater, what we used to do, we used to decrement our column. We used to stay in the same row but decrement our column. So we are just going to do a j minus minus over here. This condition over here, if this has never been satisfied, we can certainly say that we have never seen the value and we return a false. So let's run this code. Hope no errors. Yes, yeah, so it has been accepted. So let's submit and check for a broader range of test cases over here. So yeah, as you see that it has been accepted and we have a submission better than 100% of all the submissions, right? So once again over here, the idea was to give you the idea is the main lookout for me. So hope you got the concept. So hope you understand why we are taking those decisions. So this is a very simple solution. So do let me know what you think about the solution. So if you think the solution was helpful and simple, do give it a like and share with your friends as well. And yeah, that's all from this video. Do share and subscribe, and also recommend the channel to your friends. And once again, thanks for watching the video. And if you want me to solve any particular problem which you have in mind from any platform or an offline problem, do share with me anytime, and I would be glad to assist you on the same. So yeah, have a great day, and see you guys soon again. Bye bye.